Good morning, everyone. Thank you, John, for the introduction. So, I'm a chemical engineer by trade. I'm Adelaide born and bred. I've studied at the University of Adelaide, at the University of Oxford as well, and I've been fortunate to work across Australia and the Americas with BHP, but equally I'm really glad to be back home. Olympic Dam has a special place in my heart as the place where I started my mining career 15 years ago. In my operational role, the absolute core responsibility of my job is to manage the health and safety of more than 250 team members, that is, employees and contractors, across a range of working environments and risks. And I'm here today because radiation is one of those risks. I feel I'm very fortunate to be supported in monitoring and managing that risk by our radiation team, some of whom you may know already. And this is a wonderful opportunity for me to recognise and support them in turn. In particular, my colleague Neil Camillo, Manager Health, Hygiene and Radiation Analysis and Improvement. For us all, I think it's important that we recognise the critical value of technical expertise in the areas where we're seeking to manage risk. So, if you've just seen my colleague Paul Cuthbert's session, you already know that Olympic Dam is one of the largest underground mines in Australia. With over 700 kilometres of underground development and with a resource of more than 10 billion tonnes, it is by any definition a world-class resource. Indeed, Olympic Dam is the world's largest deposit of uranium, the third largest of copper, and also has substantial deposits of gold and silver, all of which we produce, and they present some unique and challenging operational requirements. This process requires us not to just separate uranium as a saleable product, but also to remove radionuclide impurities from our products and manage the radiation risks inherent to mining, milling, and processing ore, as well as to understand deeply the deportment of radionuclides through a complex processing plant. At Olympic Dam, we've been working to operate safely and in an environmentally responsible manner for over 30 years, and we're committed to the long term, committed to operate and partner well so that we can be in business safely for the next 30 years and beyond. So as the production manager for copper, I'm known to talk about our process flow sheet any chance I can get. And the top section of the slide that you see here is pretty much my baby, but I will give Paul some brownie points because he explained the process extremely well, and I won't repeat myself here, but certainly I would like to re-emphasise a couple of key takeaways to get a sense, really, of what we do in our operation. So we take the ore and we process it all the way to the end products that we take to the market. Every step is entirely within our control as we consider our priorities of health, safety, and the environment, including radiation. We recycle everything in the process. The sulfur dioxide gases from the furnaces are captured to produce sulfuric acid, which we then use in the leaching processes, and the dust and slag is again recycled through our furnaces to ensure we maximise the recovery of copper. The only way to leave our process is as a final product out the gate to market or into our tailings storage facilities. And finally, so I don't talk all day to this process flow sheet, it's plain to see that this is a complex process with many recycle streams, many different sub or unit operations, and all of them presenting with their own technical challenges. I hope this gives you a sense that we manage a vast range of operational health, safety and environment risks every day, and radiation is just one element of our broader risk management process that we control to ensure that our people go home safe every day and our environment is protected now and for years to come. We operate an extensive health and radiation monitoring program which is approved by the South Australian Government. And controls at Olympic Dam are consistent with ICRP recommendations and world's best practice. And like all risk, we seek to be industry leading in the way that we manage it. So while the regulatory limits may be 20 millisieverts per year of dosage for radiation workers, at BHP we've set an internal constraint of 10 millisieverts per year. For members of the public, the international dose limit is 1 millisievert per year, and BHP Olympic Dam has established a dose constraint of 0.3 millisieverts per year. The radiation exposure pathways at Olympic Dam are inhalation of radionuclides in dust, inhalation of radon decay products, and gamma radiation. And obviously, different areas of the operation have different levels of radiation exposure. And depending on the location or the activity being undertaken, we use different controls to mitigate risk. I'll go into this in more detail later in the presentation. But in addition to our standard engineering controls, we have a number of measures that we use to protect our people and monitor radiation levels. So we use respirator fit testing, not just the respirator as personal protective equipment as controls, but we make sure that each of our workforce has personalised fit, that fit is tested, and so that we can give them the right PPE for the job, because everyone is different, and everyone therefore has the right respirator to minimise dust and radon gas exposure. Air sampling enables us to monitor dust levels and radon decay product levels, and gamma badges allow us to track the exposure levels of our workforce. And here it's worth noting that we use representative samples of our workforce using similar exposure groups rather than monitoring all of our workforce, primarily because there is a well-established low risk of acute exposure at Olympic Dam. In addition, all vehicles leaving the site must pass through the radiation portals to ensure radioactivity is below acceptable levels. And we have an ongoing program of training, education and awareness. The list goes on. So this comprehensive program of monitoring and exposure control, supported by a very capable radiation team, is happening on site around the clock. We're a 24/7 operation to keep our workforce of more than 4,000 people safe each day. But the environment that we operate in goes much further than our mine gates. Here you can see the Olympic Dam mining lease in the centre of the map, with Roxby Downs to the south. Surrounding the mining lease, we have a number of radiation and emissions monitoring stations, and these monitoring stations capture public doses and the potential for off-site exposure. So not only do we measure and monitor the personal doses of our workforce, we also use monitoring stations in and around Roxby Downs, Olympic Dam Village and around our mining lease. And in addition to our monitoring stations, BHP partners with universities and local community groups to monitor the uptake of radionuclides to the flora and fauna around the mining lease. Not being content with only monitoring the area adjacent to the mining lease, our environment team have a broader monitoring program that extends 200 kilometres north and 250 kilometres south of Olympic Dam, where we monitor for any, not just radiological, environmental impacts of our operation. So what does all this monitoring tell us in particular about our community? Well, the total estimated dose to members of the public at Roxby Downs and Olympic Village contributed by the operation was 0.03 millisieverts per year, which are well below the 1 millisievert per year public dose limit and our internal dose constraint of 0.3 millisieverts per year. So now to our workforce. Here, we have a graph which shows us, in the mine, the annual average dose of a member of our workforce engaged in a particular activity. So you'll see that along the x-axis. Hopefully it's clear enough to read, and with the dose on the y-axis. In the mine, really what we're thinking about are the radon decay products and the gamma radiation as the main source of exposure. And you'll see on the left, production drillers receive the greatest dose. So, to reduce the exposure risk posed by the radon decay products, we use an extensive ventilation of fans and raised bores which draw fresh air into the mine and expel old air. And to our knowledge, Olympic Dam has one of the world's most intensely ventilated mines. You'll recall I mentioned our 700 kilometres of underground development. Well, our ventilation system replaces the air underground with fresh air every 12 minutes to ensure that our workforce is safe. And gamma radiation, the source of which is the ore body itself, is managed mostly through the use of shotcrete, which provides a good shield from gamma exposure while also providing ground stability support. Production drillers receive the highest dose as they are located in the active development areas of the mine and are drilling into the ore body directly. BHP has been working on an ALARA assessment to reduce doses, which include positive pressure control cabins as well as personal monitoring. Again, these doses are calculated on monitoring data and do not account for PPE being worn or other controls which may be in place, so actual exposure levels are lower. Now for the surface. This graph is similar to the one previously, activities on the x-axis, annual dosage on the y-axis. And again, our team members receive dosages far below the regulatory limit of 20 millisieverts per year and actually significantly below our internal constraints of 10 millisieverts per year. Here the y-axis doesn't even go that high. Above ground exposure is primarily from dust because of the milling, grinding, smelter tapping work undertaken in the surface facilities. And you can see here that the smelter team have the highest exposure risk on surface, so I'd like to go into that a little bit more. And because of this, monthly dose assessment reporting is completed and sent to the EPA. And I wanted to give you a flavour of what it is that my team does so well, something a little bit more candid than we usually show. So what you see here is one of my team members tapping molten copper from the furnaces at approximately 1200 degrees. And when we speak about managing a portfolio of risks, I'm sure that this starts to put into perspective what we do. Engineering controls across any of our risks are our absolute priority. And over the last 10 years, we've invested a significant multi-million-dollar amount in the upgrade of our hygiene ventilation systems, in particular above our tap holes, as you can see here. Here, it's a draft so strong that it's said to be able to lift the hard hat from your head. We also enclose the majority of our launders, which carry the molten metal between the furnaces, and again manage the ventilation of these systems to control that environment, to minimise exposure to our workforce, and to again ensure that we capture the gases and the dusts. And our procedures and behavioural controls are well established. We work with a sense of chronic unease to make sure that we're doing the right thing every day, and here you see that a respirator is being worn. So moving to regulatory standards for radiation protection. Our radiation management framework flows down from international best practice set by the ICRP to the BHP policy and procedures documentation in turn. And by law, we're required to comply with the ICRP recommendations as soon as they are made, due to this being a statutory obligation under the Roxby Downs Indenture Act. One example would be the radon decay product dose conversion factor, which was implemented into our calculation in 2018 prior to it becoming a federal or state requirement. Olympic Dam has extensive practical knowledge on the implementation of systems of radiation protection, and it's important that any policy decisions are appropriate and commensurate with the actual risks that we have been talking about today. In addition, there are strict regulatory controls on the sale of uranium that Paul touched upon. We're subject to the International Non-Proliferation Regime through the IAEA and Australia's safeguard protocols, which are managed by the Australian Safeguards and Non-Proliferation Office. Under these arrangements, BHP only sells uranium to countries that Australia has a bilateral safeguard agreement with, and all Australian origin uranium from Olympic Dam is sold exclusively for use in the civilian power industry. We believe our 3 decades of experience and data can provide valuable input to the development of radiation management guidelines and requirements, and we endeavour to work closely with the ICRP, IAEA, and state and federal regulators wherever possible. To us, and to me, out in the operation, working effectively with our local and international regulators and policymakers means ongoing engagement and, very importantly, a shared understanding of the operating environment in order to develop practical solutions. Olympic Dam is an extremely long life asset. We have the privilege of having been mining for 30 years, and the size of our resource means that we'll be mining for many decades to come. This provides us with a great opportunity to continue to look to the future as we partner, study and implement new and innovative solutions to manage our operational risks, including radiation. These solutions will no doubt include systems with a greater degree of automation and connectivity to remove people from high-risk areas, and monitoring systems to monitor our people even more effectively, all in the name of continuous improvement of safety and the work that we do. Thank you.
So we do have some questions coming in on the app, so we'll
Great,
start.
and I'd like to invite Neil Camillo, my colleague, to the stage to join me in answering the questions, and we may throw it to the team who's supporting us in the audience as well.
Yeah. So just start at the top here. Given 30 years of experience in data, what is the need for such low dose constraints?
What is the need? Our operation is based on risk. We perform risk assessments throughout the operation. Our primary objective is to make sure that we manage that risk and then we keep exposures as low as reasonably practical. And it's an ongoing process. We want to be international best practice. We want to be world leaders, which we're aiming to. And that's the process that we follow, yeah.
A couple of questions on the theme of your bioassay program. Maybe you could talk a bit about that, and do you conduct any internal monitoring for LLRD intakes?
Fortunately, as Zoe mentioned, we have the fantastic radiation hygiene team. So what I might do is throw over to one of the team members to provide an explanation, if that's okay. Have we got another microphone at all?
Is that working? We do bioassays semi-regularly for heavy metal exposure, and we have done uranium bioassays, but usually for incident response. So we haven't had, thankfully, too many incidences where we have significant contamination of uranium oxide products. But we have used bioassays in the past to do dose assessments on workers. It's not a regular thing, though. We try and prevent ingestion and inhalation rather than having to rely on bioassays.
We have time. A couple of questions related to radon. Have you adopted the new ICRP radon conversion factor, and if so, what's the impact?
So our doses are still very, very low. Yes, we have implemented the new dose conversion factor. We are still, as I said, we still have very low dose constraints and dose levels to our workforce. It's an ongoing process where we manage each risk and each area as the mine develops. But yeah, our risks are still very low, even though it has impacted us. We're still well below the constraints.
So the slide that we saw, I think the maximum was 5-ish millisieverts last year. I assume that was last year's data?
Yes.
Yeah.
And that included...
That included the new dose conversion.
The new dose conversion factor. And there was a question related to for the drillers, the percentage of radon and gamma. What was that breakdown? Was that close to 50-50?
Do you want to go back to?
Yeah. There you go. So yeah, that's right.
Okay, so looking at the dark blue, or dark is the radon
decay products.
radon decay products, and then the white
The light blue down the bottom
is the OSLD. So,
Correct.
and I can't quite read the first couple of those are the different job
That's
groups.
production drilling, and then mine raised drill.
Okay.
Yeah.
And the
Mine development.
and the top line is the maximum.
Correct.
So you see, looks like about 5 millisieverts
just
for
under.
maximum dose.
Yep. Correct. Yep.
Okay. Thank you.
Thank you very much.
Thank you.